Hi, sixth graders. We're on lesson 6-8, which is scale drawings, and it starts on page 320 in your textbook. The learning target is being able to solve problems involving scale drawings. So set your notebook up the correct way, and then I want you to write down a couple vocab terms. Scale drawings or scale models are used to represent objects that are too large or too small to be drawn or built at actual size. So a map is a really good example of this. A model airplane or a model of like a city or a town or something like that are examples of scale drawings or scale models. A scale is the ratio of the measurements of a model to the measurements of the real object. So if you want to pause and write these down, that would be awesome. So we're given a map and it says what is the actual distance between Hagerstown and Annapolis. So we can see here's Hagerstown, here's Annapolis, and our key is 1 centimeter equals 24 miles. So we measured with a ruler and we got about 4 centimeters on the map from Hagerstown to Annapolis. Okay, so now we need to write and solve a proportion to figure out what's the actual distance in real life between the two cities. So we're going to set up a proportion. I'm going to put a line under here. And we know that 1 centimeter goes with 24 miles, so that's going to be our scale over here. And then the length, we know, well, we just measured 4 centimeters, so we want to know how many miles that would be in real life. And then our numerators are both the map distances, and the denominators are both the actual distances. So we need to make sure we're lining up our numbers correctly vertically in each of our proportions, but also horizontally with map and actual. So then if we multiply our cross products, we would go 1 times d and 24 times 24. So we would have, 1d equals 24 times 4. And then right over here, 1d is the same as d. 24 times 4 is 96. So it means that in the real life, it is 96 miles between Hagerstown and Annapolis. On the blueprint of the deck, each square has a side length of ½ inch. What is the actual width of the deck? So here, each square, so we want to find out the width, which would be from this side over here to this side over here. Okay? Well, it tells us that 1/2 inch on the blueprint is actually 4 feet in life. So we have 1/2 plus 1/2, which is 1, plus 1/2 plus 1/2, which is 2. Okay? My 1/2 and my 4 together, so 1/2 inch over 4. And then my 2 inches, because that's how much it is on the model, 2 inches over W feet. So then we solve 1/2 times W, and then 4 times 2 is 8. So 1/2 W equals 8. And then we can either multiply by the multiplicative inverse, or we can solve. But we have, so now we have that the deck is actually 16 feet. So 1/2 W, we would multiply both sides times 2 over 1. So 8 times 2 equals 16. Alright, so if we have a blueprint of a living room, each square has a side length of 1/4 inch. So it's telling us that each side of our living room, or each square, is 1/4 inch. So, and this is on the map here. So we know that on the map 1/4 times 4 would be 1. So 4 squares would be 1 whole inch. And then we have 3 more squares, so plus 1/4, plus 1/4, plus 1/4. So this side is going to be 1 3/4. And then this side, 1, 2, 3, 4 is 1 inch. 1, 2, 3, 4 is 2 inches. Okay, so we need to find what are the dimensions. So first we need to figure out what would the width be. So we have 1/4 inch equals 1 1/3 feet. So 1/4 over 1 1/3. So this is inches and this is feet. And then we're given on our map, we know, excuse me, we know that one of the sides of the living room on our map is 1 3/4 inches. And then we want to find out the actual dimensions. So what we're going to do, excuse me again, is we are going to multiply our cross products. So we have 1/4 x equals 1 1/3 times 1 3/4. Okay, so we are going to multiply this out. So to multiply fractions, we need to change it to improper fractions. So 3 times 1 is 3 plus 1. So we have 4/3. And then we have 4 times 1 is 4 plus 3 is 7/4. I can actually, because I have a 4 on the top and a 4 on the bottom, and I'm going to be multiplying them together, I can actually cross both of my 4's out and just have it as 7/3. Because 4 over 4 is just equal to 1, so we can cancel that out and not even add that into our multiplication. So then over here we still have 1/4 x. We look at our variable with our side with the variable, which is x, and we're going to multiply both sides by the reciprocal, as we recall. So we have to do that over here. So 7 times 4 equals 28 over 3. And then we know that 3 can go into 29 times, which is 27, so we have 1 left over. So one side of our living room is 9 1/3 feet. Okay, so now I want you to pause me and set up a proportion and do the same thing with this side of the living room, which is 2 inches. Okay, so I'm going to keep my same proportion on the left side because we still have the same scale. So we have 1/4 inch times 1 1/3 feet. This time we have 2 inches on our map that we want to translate into the real world over x. So now I'm going to multiply my cross products. So 1/4 times x equals 1 1/3 times 2. So I'm going to write that over here. So 3 times 1 is 3 plus 1, so we have 4/3 times 2. I'm going to put a 1 over it, so we end up with 8/3. Oops. And I'm going to leave it like that. So 1/4 x equals 8/3. Because I would have had to return it back into an improper fraction, I'm just going to leave it. So now we're going to multiply by the multiplicative inverse, which cancels that out. But then we have to multiply 4 over 1 over here. So 8 times 4 is 32 divided by 3. And then we know that 3 goes into 32 10 times, so that's our whole number. And we have 2 left over, so 2/3. So the living room would be 9 1/3 feet by 10 2/3 feet. Okay? And then the last thing that we have is scale factor. So in 6-4, we used ratios to convert units. We can use a similar method to simplify a scale. So I want you to write this word down, scale factor, which is written as a ratio without units in simplest form. So let's look over here. If we're given a key on a map, 1/4 inch equals 2 feet, like that's what it would say on the key of the map. Well, we can convert the feet to the inches. So we know that in 2 feet there's 24 inches. So 1/4 over 24. Now, what we could do, and we could just, so 1/4 divided by 24 would be the same as 1/4 divided by 24 would be the same as multiplying by 1 over 24, because you would flip it, 24, the reciprocal of it. So 4 times 24 equals 96. So we end up with 1/96. So that would be our scale factor. The reason in the book they did 4 over 4 was to get rid of that 4. And then we were still multiplying by 24 by 4 anyways. Okay, so our scale factor is how much the scale drawing is, or the model is, how many times less or greater it is than the real thing. Okay, find the scale factor of a model sailboat if the scale is 1 inch. 1 inch equals 6 feet. So we write 1 inch over 6 feet equals 1 inch, and then we convert the feet to inches. So we know 6 times 12 equals 72. So then our scale factor would be 1/72. What is the scale factor of a model car if the scale is 1 inch equals 2 feet? So I would write it as 1 inch over 2 feet equals 1 inch over 24 inches. So we don't write it with units, but this would be our scale factor, because if we multiply 2 times 1, we get, okay, wait, I'm confusing myself here. Oh no, we don't proportion it out, we just leave it as 1/24. So our scale factor then is 1/24, because we're given that it equals, so 1 inch equals 2 feet, but 1 inch also equals 24 inches because those are equal. Okay, so make sure you log into Naiku and take the 6-8 quiz, and you can also look back in your book or look on the textbook for some more examples and more resources. Have a super evening, and I will see you tomorrow.